We're going to learn some new skills today. We're going to look at law of sines and law of cosines. We're just going to focus on the law of sines right now. This is basically trigonometry with acute and obtuse angles. So if you don't have right angles, you can still find missing parts of right triangles. Okay, so we're going to start by naming missing sides and or angles. So for example, in this triangle, they give you the three vertices. What we need to do is come up with a name for each side. And you can name it, for example, this is segment AB. If you want to just call it segment AB, you can. But what we're going to do instead is we're going to name this segment lowercase c. And the reason we do that is it's across from angle C. So this segment, AC, we're going to call it lowercase b because it's across from angle B, capital B. Segment BC is across from angle A, so we're going to call that lowercase a. So instead of just randomly calling this side X or this side Y, we're naming it due to the name of the angle that's opposite of it. Number two, same concept, except they give you the segment lengths. So we're going to call this angle, angle D. Notice how it's capitalized. This would be angle E, and this would be angle F. This guy's a nice mixture of the two. That would be L. I used a cursive, obviously, because if I draw lowercase l, maybe it doesn't look like an L. That's angle W. That length, we would call that lowercase t. We're doing this that way we're all on the same page with what lowercase b refers to. It's a side length that's across from that angle. It's the same letter, just a capitalized version of it. So the law of sines is going to allow us to find missing pieces when we don't necessarily have right triangles. And we're going to apply this law of sines when we have arrangements of parts. So if we have two angles and the side included, we can use a law of sines. Or if we have two angles and a side that's non-included, we can also use a law of sines. Or if you have one angle and two sides where the angle is not included. So angle, 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 side, or AS is where you would use the law of sines. And here's what the law of sines says. I have it written as an extended proportion. But let's assume the triangle ABC is any triangle where lowercase a, b, and c are measures of the sides that are opposite of the angles with those measures, capital A, capital B, and capital C, respectively. Here's what you know. This side that we're calling lowercase a, divided by the sine of the angle opposite of it, has to be the same as lowercase b divided by the sine of the angle opposite of it. These fractions are proportional. And these aren't special angles. Notice how angle C, it also works for it. This is the same thing for the length of C divided by the sine of the angle opposite of it. It's going to make more sense when we look at an example, and we'll do that in the next video. But keep in mind, your law of sines is a proportion where we have a side length on top and the sine of the angle opposite of it in the denominator.